everyone has something unique encoded within their DNA. This something is what we call the genetic code or sequence. Billions of nucleotide bases arranged in unique combinations in every single one of us. It is this genetic sequence that we forensic officer use to identify a person. After we collect samples of DNA such as blood and hair from the crime scene, as well as the DNA samples of different suspects, we do tests to see who was actually in the crime scene and left their DNA samples there. To do this, we need restriction enzyme. It is a type of endonuclease, an enzyme that recognizes very specific short sequences within a DNA molecule. When it recognizes the sequence, it breaks the phosphodiester bonds that hold the long chain of nucleotides together. This will cut the DNA molecule at wherever this sequence occurs. This means that with everyone's unique DNA sequences, the same restriction enzyme can cut them into fragments of different sizes. One person may have his or her DNA molecule cut into 100 fragments, each of different lengths, while another person may give 200 fragments of different lengths. These fragments can then be separated based on their sizes with some radioactive imaging. This will in turn give unique band patterns on the testing device. The key is, no two people can give identical band patterns as their DNA sequences will never be 100% the same. While one restriction enzyme recognizes and cut one and only one specific sequence. By using the same restriction enzyme to cut DNA samples collected from different suspects and the DNA found on the knife, we compare the band patterns they give. If the bands resulted from the DNA found on the knife is identical to any of the suspects, it confirms that this suspect held the knife.